Okay, now it's recording. Okay, today is my turn to do the class. So let's see how it works. Let me share my screen first of all. Okay, now I imagine you can see my empty screen. Okay, so for this class, we will start with processing. Okay, when it's processing and P5, I will explain what it is, but we will center the class mostly in, well, totally in processing, because finally those two softwares are more or less the same. So with explaining processing, we are explaining also P5, like the basics of it. Okay. So what we'll do here, we will go through some like basic codes and software and programs to learn the basic features of processing and how to interface with them with it. Okay, and how to connect the Arduino, for example, to processing and talk between the computer and the Arduino. Okay, so let's start with a brief introduction of processing and what it is. So processing, you can see his webpage, where you will find everything about it, from tutorials, examples, everything here. Processing, it's an open source software. It's so it's free and open source. It was born in 2001 and it's like the predecessor of Arduino. Okay, so the Arduino IDE is based on the processing IDE. So it's a pretty nice developed software. Okay. So finally, what it is, it's a programming language based on visuals. So it was created to create visuals into the developer environment and has a very big online community. Okay. Like everything you need to program in processing, it was done before you. So you can search it on the internet and you'll find everything there. Okay. So it's important to know that it's Java based. So when you are, it's like an upper level of Java. So it's like a mask of Java. Like Arduino is a mask for C, processing is for Java. But also we have like different options if we want to have it in different languages. For example, P5, it's a JavaScript. So it's a web-based software. So it's mostly like processing, but in the web. Then we have processing PI, that it has a Python coding. And then we also have processing for Android, that it's developed for applications and things like this for mobile devices. Okay, it's super easy and friendly to learn software, mostly like Arduino. So it has the same shape as Arduino. It works the same way with different loops that goes through the program and run once and once at once. Okay. So here you have some links to tutorials and references. Okay. As I said, there is a super huge community of processing followers, let's say, everything is done. So it's super popular as a creative visual software because it's easy to create mathematical and geometric shapes with it on the go with inputs, and it's very like a creative code software. Let me explain a little bit how it works. Okay. For explaining the functions, I prefer to go through the examples than going through the slides, because like this you will see what it's really doing. Okay, so what we create now is a basic example of a bouncing ball, but let's create it from zero. Okay. Let me open one processing here. Processing. So this is the IDE, fantastic IDE. No? I'm sorry if you see. Can you see what I'm typing? It's really small. It's okay.
Yeah.
It's okay? Perfect.
We're quite small.
Yeah, quite small.
Let me see if I can zoom in somehow.
By the way, can you work in processing using other IDEs, like, for example, Atom that we have Platform EO and the web page, or is it exclusive to work with the processing IDE?
Like here in the IDE, what you do is write the code, but also the IDE is the one in charge of running the program. So for running the program, you will need the IDE, or well, for sure you can search the internet on how to do it, because it's only code and then running it in Java. So I'm sure that there is a way to code it not in the IDE, but somewhere else. But I don't know.
I don't know that either, but there's an active forum in the processing page, and in there's like people talking about it. I'm very sure that there's like a way to just plug in an Atom or Sublime or something like that. At the end, if you open the file of processing that Josep is going to write now, it's a text file, the same as a Python file or the same as.
Yeah, there is an Atom plugin for processing, but you will still need to have the processing ID installed on your computer. But you can write.
It's probably a little bit like Arduino, that it says use external editor, and you still compile with Arduino, but the editor is the one that is modifying the text. And in Arduino, you just click the two buttons to compile and upload. You know that you have that option as well in Arduino, right? There's in preferences, it says use external editor, and the screen goes gray, and then you can start using another text editor and just compile in the Arduino IDE.
No, I didn't know.
Yeah, well, okay. Okay, you can go.
I will magnify it a little bit like this. Now you can see better what I'm writing, more or less, no?
Yeah.
Yeah, okay. So, wait a second, because there is. Okay, now. It is complicated, the magnifier, okay. See if I find a way to do it right, because if not.
When you do in your preferences of the sketch, do you have a bigger file, a bigger font?
Okay, yeah, perfect. Nice, super huge, no? Perfect, no? Okay.
There you go.
It's too big.
Thank you. Thank you, too big? Okay. Okay, thank you, Benji.
No, I was kidding.
No, I will put it a little bit smaller, because like this we will see more code, okay? So, let's go drawing the basics, really basics. Let me open here this page in the other screen, so like this, I will try to follow a little bit and see, explain you. Okay, so this works mostly like the Arduino IDE. So we need some void loop functions to make it work. Okay, as the Arduino IDE, we have two main loop options, like are the void setup exactly the same. And then we will have a void draw. So as Arduino, what it does. So the byte setup is just setting up the major parameters. This loop is only running once when you start the program. Then it will not run again. So it's just you want to make some calculations, for example, that you only want to run once. You can make them here. So you will avoid the program to make them each loop. Okay. For example, if you want to set, for example, here we will set the size of our screen. It's 14 pixels, so I will do like this. Okay, yeah, you can put whatever size. Okay, and this will only run once at the start of the program, like the Arduino. Okay, and here the draw, it's a loop that will go. It's like infinite loop, where you can define what you want to draw in the sketch. Now, here you have the play button. So if you play here now, you will see that it opens in the screen. This is the screen that we open. It's a screen of 600 pixels per 900. Okay. So let's start with the draw. Let's draw something now. For example, if you want to draw a rectangle, it's as easy as putting here rect, and then you can define the coordinates of it. Okay, so we will define the first corner, let's say 100, 100, and then the other corner. So it's the top left corner and the bottom right corner. Okay. 100, 100, let's say 200, 200. So if you run it here now, it's a bit slow. So, okay, you see, rectangle appear now. Magic, perfect. How we can define more things about the rectangle? For example, we don't want this the black line out here. So all of the functions of the shapes that we want to create, we have to define them before we draw the shape. Okay, so the function rect is drawing the shape. So what we want to do is, okay, we don't want a stroke. So we have this the command no stroke. So you define no stroke, then you draw, then your drawing will be without a stroke. No stroke. You want to color it, you can fill it. So we want to fill with color black, for example. Okay. Color black. How the colors work? The colors are easy to, like you have two different ways of, well, you have a lot of different ways to color things. Like the main two are, first of all, if you put a number from 0 to 255, it will be from black to white. So it's in grayscale, so you can define which step of the white grayscale you want to be. And if not, you can define the RGB color, like the normal thing. So 255 to 255, 255, this will be white because it's RGB out to the full level. So if you do, for example, 0, 0, this will be red, okay? So it's red, green, and blue. Okay, and also we can add a 4 parameter that is the transparency. Okay, so if it's also from 0 to 255, so if we 100, for example. Well, now, because we don't have any background, so we can see anything. So how to define a background? No. It's the first one. So we have a function called background. It's for giving color to the background. Let's say we want it black. Okay, here you can use the background, but also if you want, you can like create a rectangle that covers the full screen, of course, no? But the background is like most straightforward. here you can see, like now it's the transparency is acting here, so it's red, but going to like darker red. If we put no parameters here, it's fully red. Okay. We can create also, like, if we want to create a circle, for example, we can create an ellipse. And here you define the same thing. You define, first of all, the corner of the center of the ellipse. So let's say here 300, 300. I'm just messing up a little bit, so I have no idea what I'm doing. Let's put it 100 by 100 like the square. Okay, so we have here the little, let's move it a little bit to see it better. Let's make it bigger. Okay, here you have the sphere, you have the square, no? Why both are red? Because we set the field here, so it's acting to both of them. Okay, so it's always important to remember to change the parameter before you want to do something. Okay, so if here we fill it with another color, I don't know, let's make it white. Then you will see that the circle is white and the rectangle it's red. Okay. So here we have for these like basic shapes, we have different modes. So let me go, for example, here.
Can I ask something?
Yeah, of course.
So depending on what you draw first, I mean, it's gonna appear on top of the other. So for example, if the ellipse was like inside the rectangle, it would appear as if it was on the top of the rectangle.
So yeah, it's like it's like a linear program. So the first thing you draw, it's in the back. So when you draw on top of it, it will cover it. So here, for example, you see that the ellipse is covering the rectangle. Okay, so it goes line by line, drawing without knowing what it has drawn before. Okay. So here, here in the processing page, for example, you can search whatever. For example. Okay. So here, for example, for the rect, for the ellipse, all of them, we have modes to define to set what we want to define. No? For example, like the normal rect mode is corner, where we define the corners and the size of the square. Okay. So I'm sorry because I did a mistake before. No, I said that this was the other corner. So not it's the size, the width, and the height. Okay. So if we want to make this the other corner, so the bottom left corner, we have to change the mode. So we can change it here to mode to corners, and then this is defining the corners. Okay. We can also we will see that now it will be smaller. Yes. Sorry. We also can set the radius, the centers. Like here, I truly recommend to go through the processing documentation. It's a super nice documentation where you have everything explained on detail. So with any doubt you have, you can search like super easy. Like I don't know, no, you want to make a circle. So you will see circle ellipse. You can have like different documentation available here, and it will explain everything, which are the parameters that you have to use, what are they, and how you have to set them. Okay. Okay, you have the related. So for example, ellipse mode, how to define. If you want to define the center, you want to define the radius, the corners, whatever. Okay. So let's go with something more special, no? Because okay, we can work in processing. We can work in like for defining where the drawings are set. We can work in like global mode, like now that we're defining. Okay, this is the global point, starting point, or the global center. But also, if you want to use like more like relative path, relative coordinates, you can translate the origin. Okay, so for example, here you can say, okay, translate to 100, 100. So now the 0, point will be at 100, 100. So the starting this center in the global program would be 400, 400. Okay. Also, it's like the fill and the no stroke, looking like this. After you translate it, all of it will be translated. So if you want to go back, you have to translate to 0, 0. Okay. Yeah, let me show you. Run it fast. You see that the circle move down 100 and 100 to the right. Okay. This is a loop. So, for example, let's say here we can define variables. For example, now we will define an integer that will be the speed. Let's say the speed is 5. Just a number. Okay. So as this is let's say let's define the location. See the way. Now let's put it at 300 in the middle of the screen. Okay. So let me delete these ones. Because I just want to work with the sphere now and say, okay, I have this sphere and I want it to be at the, well, let's say, let's do it the other way around because it's Y, X. So let's start here, okay. I want it in the center of the screen. So this will be 800 instead, like, it's the half of the size. Also, what we can do is we can do with half 2. And then here I want to have it in the location. Location Y is the half of this. So also if you want, you can say. Oh. Okay. So it will be in the middle of the screen. So, no, sorry, I have a, you can see here the error, no? Why? Because I'm defining the height while it's not defined, okay? So I cannot put it here. So I can do is put this like this. In the setup, you can say, okay, location Y. Oh, yes. Okay, now we have our circle here in the middle. Amazing. Okay, let's move it, no? So we can say location Y plus equals speed. So here what we're doing is just saying, okay, each round of the loop, it will say, okay, when it finishes drawing the circle, then it will increase the location Y to 5, that is the speed. Okay, so this plus equals is the same that equals Y plus speed. See the ball moving here. sorry to be, I'm sorry because it appears in the other screen. Let me decrease the speed. If I want less speed. So I can show you how it moves now. Okay, so here you can see the ball moving. But what happens? It's going out of the screen, no? So we don't want it to be here out of the screen. So what we can say, it's really, it is like Arduino, no? We have the if, we have whiles, we have for, so we can, the programming language of it is pretty much like Arduino. So let's make if the location, right, it's bigger than the height of the screen. So let's say if the location is bigger than the height of the screen, let's say, let's make it, let's flip the speed. Okay. So let's say speed.
The variable speed is speed, not speed y.
Yeah. Okay, so let's see what happens now. It is slowly moving. It goes up, but we'll have the same problem, no? It will go up and disappear. So we should make it like also, let's see. Minor equals 0. We'll do this exactly the same thing. I can make it faster if you want. It goes crazy. So we have our first moving check. Amazing.
Can I ask something?
Yeah.
I'm wondering, because we are adding location with speed.
Yes.
So 8, for example, at speed, what does it mean? Is it just the pixels that it moves?
Yeah. So in each loop, it will move like 8 pixels up, no? So for this is the speed. So if it only moves 2, it's slower. And if it moves 8, it's faster, no? So if I increase the speed here, let's make it 18, for example. What it's doing is in each loop, it will go like, it will increase the location in 18 or decrease it. Okay.
What's the default frame rate? Or how often does it refresh?
You can change the frame rate. You can change it like this. So I think the default one is 30 frames per second. No, it's bigger because this is slower. No? So maybe the default one can be 60. Okay, but you can define here the speed of it. Okay, if it's 10, it will be slower. Yeah, you can see here like the movement is super slow because you can see like in that many less frames, like the movement is not fluid. Okay, let's comment this one. Here it's like commenting, like Arduino or anything. So now let's make it a little bit more accurate, and let's define also gravity. Okay. Here we can say gravity. Simple. How we will use the gravity? It's okay. Each time the loop goes in, we'll have to add in the speed. We'll have to add the gravity. So the speed y plus gravity. So this parameter is adjusting the acceleration of the movement. Okay. So in each frame, the speed will increase 0.2. So it will go faster when it goes down and slower when it goes up. Okay. So here you will see.
You need to remove the y,
Yeah.
no?
Let's float. I need to remove what? Sorry.
Is it speed y or just speed?
Yes, it's just the speed. Sorry. The speed y. Y. You can see it's highlighted in red where there are errors. It's highlighted in red here. And also if you try to run it, it will say no. Sorry, you can't run it. Okay. So here, it's difficult to see it here because but it's much faster here in the low. Let's increase the gravity. Say, okay, here you can see the gravity, but it's not allowing us to go to the top of it. Okay. But we also have, like, if we want to simulate a real bouncing ball, we also have like the friction, no? And we lose energy every time we hit the floor. So how can we do it here? We can set here. We can say, okay, every time it touches the floor, let's put at the speed. We multiply it by something like this. So 33.75, for example. So every time we will reduce the speed in every hit that when we hit the ground, we'll reduce the speed. Like this, we will have like a real bouncing ball. Okay. To avoid problems, let's make here every time the location is bigger or equals the height. Let's set the location y. It's because we don't want to go lower than this. So every time we go lower, we stop it there. And here you have the bouncing ball. There is one point that it reaches like stability here. So we will do like little bounces here. This is because like the system, it's not a real system here, and it's getting to an equilibrium, to a static point where the speed hitting the floor is always the same, and when you multiply it by 0.75, it's always the same. No? So it's a static point here. So okay. If we want to debug the program, there is a really useful tool here in processing that is the debugger that I would love to show you, but I will not be able to, I think, because I have a problem with processing with my installation. I don't know why the debugger is possible. This is always okay, but I really encourage you to check the debugger, and if it works for you, amazing. Okay, this debugger is super useful because you have here to go step by step, or you can like set here breakpoints. For example, let's say I want to stop every time I change the speed. It will not work for me. No, it goes easy always. Okay. So you can go step by step or continue the program to make a whole loop again to go back to this function here. Okay, and what it does also, it opens you a little screen with your variables. So you can see in each loop how the variables are evolving. So it's pretty useful to see to the back. Okay. If it's not working, like in my case, what I can do I can print here in the console. Okay, so here in the program we have a little console here. So for example, if every time I change the speed, I can print in a new line the speed, for example. And now when I run the program, you will be able to see it. So this is the speed in each of the frames. So now it's super fast here. Okay, but you have like a lot of okay. So also if you want to debug simple things, you can use the print. It's pretty useful. Okay, you can print line or print normal print. Normal print will print like all of them together. Let's see here. So it's all the numbers in the same row. So it's always easier to see it with print line. Okay. Okay, nice. But let's make something interactive, no? Because this is okay, but it's pretty static, let's say. It's like a video, and we don't want to make an interface. Well, maybe yes, but it's not like the aim of this session. Okay, so let me start a new. So. One second. Okay. So let's define the point setup. Okay. So I will start with the size like the other. Here you can define whatever size you want. Okay, like this one because it looks nice in my screen. But like really, you can define whatever. Let's say background 0. So I set the background here in the setup, and I don't set it up more times during the loop. Okay. That you will see. Here we will see the example. Okay. Then let's create an ellipse. Let's fill it in white. We'll create a circle. So okay, this circle should be X, Y, that is the center of the ellipse. And I don't know like, let's say 100 by 100. This is the size of the ellipse. So okay, this X and Y, if you want to make it like more interactive, you can set them, for example, to the mouse position. Okay, so here we have a built-in function that is built-in variable, really. The mouse X. Mouse X. So here, let's see. So here, okay, we have the black background. And when we pass the mouse here, we're drawing, okay? Because we're creating a circle in every position that the mouse is moving. Okay, so this is way much more interactive, no? So you can see that it's keeping all the circles that we're drawing because we're not drawing again the background. So let's change the program here and say, okay, I want to change the background. I want to redraw it again. So like this, we will cover all the circles that we draw. So now we will have like a big pointer. You see, now it's only drawing the circle in the mouse position, not the other ones. Because in each loop, we draw the background, so we delete it, we cover everything in black. What if we want to have like a fading effect? What we can say, it's okay, to make a fading effect, what we can do is say, okay, instead of using the background here, because the background should be a solid color, we can fill a rectangle with 0 and some alpha parameter that is the transparency. We can create a rectangle that covers all the screen. No? So it will start at 0, 0, and it will have the size of 60. So here you will see. So this is the color, and this is the alpha parameter that defines the transparency of the color. So here it's drawing first a whole rectangle and then the ellipse. No? So here you will see that we have like a little fade effect, and depending on the transparency, you can have higher or less effect. Say 50. You see that we have way much more fading. Say 10. So here we have way much more fading. Okay. More interactive things that we can do is we can also read the clickings of the mouse. Okay, so say okay, I want if let's say okay, if let's say okay, what I want to do now is like when I press the right button or the left button, I will delete this fading effect. So everything will stay in the screen. And then when I unpress it, it will start fading, okay? So I will say, okay, if not mouse pressed, so here the exclamation mark is the negative. So if the mouse is not pressed, okay, like this, it's understanding the left mouse, the left button, okay. Also, we can say, we want to do it with the right one, we can say mouse. Well, mouse not pressed, it's, okay, mouse not pressed is anything, okay. But for the mouse click, we'll define there. So if mouse not pressed, I want I want this fading effect. So I create a rectangle that covers everything. And here, if I press the mouse, it will not go in this loop here, this if function. So let me show you here now. Okay, we have the fading effect, and when I click, the fading effect disappears. So I can write here, hello. And when I unpress the mouse, then it starts fading again. But for example, let's say I don't want this to keep the history of the fading effect before clicking. So here we have the fading. Then when I click, I have all the history here and I don't want it. So let's say, okay, let's see if here I'm defining that if the mouse is pressed and the mouse button that is pressed is the right one, I want to delete I want to set the background to 0 again.
What's mouse button?
Mouse button is defining which button is pressed, okay? So this is, if you press, so here right is the right button, here it's equal, right is the right button and left is the left button. So we have the, and also we have the center, that is the scroll wheel, okay? So here, now we'll see that it will not work as we want. So it's also having, so here we have the problem. So we have this. And then, but we are not, like we're defining the background to 0. So we are deleting everything. So we cannot say, okay, I want this. I want to see only, I want to like start drawing with when I click the mouse. Okay, so. Sorry, here. Because we don't want to like redraw the background every time we press in every frame that we have the mouse pressed. So what we can do to create like a button, let's say, it's to create a variable. For example, we can make it an integer or boolean. So, okay, we have a boolean here. It says, okay, mouse click, it's false. And so if the mouse is pressed and the mouse click variable is false, then we draw the background and we set the mouse click equals true. So what we're doing here is, okay, then we will not go inside this condition unless we unpress the button, and then here we set the mouse click to 0 again to reset the variable. Okay, so we have this, and when we press, now you can draw without the fading effect. Now, when you press, you have you continue with the fading effect. Okay, so here is the right clicking. So if we want to make it with the left, this is left clicking. So if we want to do it with the right clicking, is the thing that I was showing before. It's mouse button equals right. Okay, so I will only go inside if I have the mouse pressed and the button I'm pressing is the right one. So here, run. Okay. So here, with the right button, it's working with the right button. Okay, pressing the right button. Okay, this just defines the button that you can press. Okay. Okay, so these two examples, I think we cover like the really basic features of processing. So let's go to something like a little bit further. Let's connect our Arduino to processing. Okay. So first of all,
Can I ask one more question?
Yeah, whatever.
Can you please re-explain the else if, what it does?
Here, okay, so it says, okay, the else if is a condition after this one, okay? If this one it's not entering here, it will try to enter here, okay? So what it does is, okay, if the mouse is pressed, so this will be true. When you click, this is like an internal variable that it will be set to true if you click any of the buttons, okay? So, okay, if any of the buttons is pressed and the mouse click is false, so we have this variable that we created here, just to know if it's because mouse pressed, when you press the mouse, you can press it for 1 second, for 2 seconds. So the program will read the variable as pressed for long as you have the button pressed, okay? So to read only when you click, like the first click, not if you keep it, click it, I create this variable here to say, okay, the first time that you click the button, so the first second you press, the mouse is pressed, this variable will be false because we set it to false here. And if we have the button that we have is the right one, if it's the left one, we will not enter here because it's not fulfilling our condition. Okay, so it will enter here, and then what it does is, okay, I redraw a background, a black one, so I delete all the fade effect of the previous movements, and then I set this variable that is the one that the mouse was clicked to true. Okay, so in the second that you have the mouse pressed, it will not enter here this function because this variable will be set to true, so it will not fulfill our condition, so we will not be able to enter. Do you understand? Yeah, perfect. Okay, so let's connect the Arduino. Okay, I have two super simple examples prepared. So let me turn on the camera of my computer. I'll show you my super setup here. Okay. So here I have the Arduino, okay. We'll go through two examples, one with an LDR here, and one with 3 LEDs and 3 buttons, okay. Let's start with the LDR. It's the connection, it's like super easy, like a normal LDR. I have the LDR connected to VCC and connected to an analog pin, and then from this analog pin with the resistance to ground, okay? It is like the normal LDR. And let me show you the code of the Arduino. It's super simple. Okay, here, let me do it bigger too. Let's make it 24. Okay. So this is the code of the Arduino. Okay, it's what we define here is okay. In mode, it's an input. We start a serial communication, and we read this sensor and we print it in the serial. Okay. So let me go back to the documentation. This one. Like this. This is the documentation. Okay. So this is the bouncing ball. All the codes of these examples you have them here. Okay. So let's go to serial communication. Well, this was an example of the interfacing with processing. This was my assignment for last year. So what I did is connecting the neck of the ukulele with the processing. Let's make it bigger. So here you can see that when you play, it's lighting up here in the drawing, and also the other way around. So when you light it here, you can light the device, okay? This is pretty simple to do. So to communicate the Arduino with the computer, we use serial communication, okay? This is why processing, it's easier processing than P5.js, because P5, as it works in the web server, it's more complicated to access the serial ports. Okay, with the processing, that it's a local program, it's super easy to like open the communication with the serial port. Okay, so the Arduino has the serial port with the USB, so you can connect them, and it's pretty straightforward. I imagine that most of you have used serial communication before with Arduino. So I want to explain the difference between the two printing functions that we have. Okay, that is the serial.print and serial.write. What's the difference between them? So the serial print, it's printing the ASCII code. So you can print the string, for example, you can print a number, anything. So it will translate it to ASCII and send it in bytes, okay, to the serial port. serial write, it's writing like it's sending only one byte. Okay, so it's byte by byte. Okay, this allows you to have a more fast and simple communication. So serial communication, it can be tricky to read whatever you want to read, and you can have a lot of, if you use the serial print, you can have different characters there that can mess up a little bit your reading. So if you can try to like define a protocol of communication, it's always like easier and most stable. Okay, so here I wanted to show this because after I will explain how I like codified my communication and the problems that I really avoid doing it. Okay. So here is an example. For example, if we want to send hello with write, what we do is sending byte by byte and then translating it to letters. And with the serial print, it's serial print, you can send the string, okay? But then for reading, it's more complex, let's say. You can have more problems, okay? So let's start with the LDR. Let me show here the code, okay? This is the code, super simple. Just reading, sending, reading and sending, okay? I'm sending here with print line, okay? This is also to show you how it works the print line and how it works the write. Here also the lecture, it's an analog value from 0 to 1023. So I cannot write it in only one byte. So this is also useful to use the print line. Okay, or you can send 4 bytes and then you have the number, okay? Or 2 bytes, right? Okay, so that's the code, super simple. If you want, let me upload this code to the Arduino. I think it's connected, yes. Let me show the camera here. Like this. So we have here the LDR, the Arduino. Computing scale is a little bit slow. Okay. Super slow, it's okay. It's taking forever, I don't know why. No, okay, loading, okay. Done. So here, if I open the monitor, here you see, this is the value of the LDR. So if I flash it with my mobile phone, for example, this will go up, okay? So yeah, can adjust a little bit the threshold there, but it's okay. Adjusting the resistance, we can have more lecture of it. Okay, so let's open the serial communication with processing, okay? Let me open a new one. New. Okay. Here, so using the serial communication, we have to import a library here. So if you go here to Sketch, we have libraries here. You can add new libraries if you want, but you have here the serial one. It's by default you have it installed. Okay. So here, import processing serial. Then we have to like open the serial port here to say, okay, let's create serial let's call it my port. So now I'm from the class serial that is inside the processing serial library. I'm creating an object that is my port. Okay. And let's start with the void setup. Void setup. Setup. Okay. Let's go with the setup. Let's make a size like always, using always the same size. So perfect. And let's open the communication. Okay. So let's say my port is equal serial. So this is opening the serial communication. I will say, okay, this is referring to this, like to here in this code. Okay, like this is the where you want to open it, more or less. Okay, more or less. Let's open which port we want to open. I know my Arduino is in the code 17. I can see it from here in Arduino if you want. Tools, port, you can see mine is at COM 17. Okay. And let's define the baud rate. The baud rate is the speed at which it will communicate. So here in the Arduino, I said, okay, the serial is talking at 9,600 speed. So I will have to define the same one here. Okay. But we have our communication port open. So now let's read it. This is just reading the port. So let's say, okay, let's check first if we have any information in the serial communication in the port. Okay. So let's check my port. If there is information available in my port, so if is my port available is bigger than 0, this is what it does. It's my port available. It's saying, okay, you have that number of bytes available in the port. So they send you the number of bytes. So if it's bigger than 0, we have information they're waiting. So what we can do is, okay, let's read it. As it was a print line command in Arduino. Sorry. So we have here print line. We'll try to read it as a string. Okay. This one. Okay. Let's create a string where we will save our lecture. Okay. Say call it lecture. Let's go to 0, for example, to start. Okay. So let's say lecture. Okay, here we have different options that we can make read, but read it's reading only 1 byte. So we read the first byte, then read the second one, and we can buffer them. But we have a function that is read string, and another one that is read string until. It will read a string until the character that is defined here inside the parentheses. So I will write here this character is the new line. Okay, so the new line, doing here the print line function, we're printing the lecture plus a print line character, like a jump line. Okay. So I will read the string until this character, and then I will stop. Okay, so the lecture will be only this reading. So what we can do here is, okay, let's translate here inside this function. We can translate this lecture to a value. Okay. To avoid problems, let's make if lecture is different than null, because sometimes we can read null values from different, we can have a problem or something and we can have a null value. So if we don't want to read this null value, we can say, okay, if the lecture is not null, what we can do is first of all, lecture equals in the lecture. Trimming is getting rid of all the white spaces, black spaces, junk spaces, like everything. Only getting the letters, okay, the characters, like the visual characters, and then translate this one into an integer. So let's create another variable. Let's say val for value, and this is 0. Let's say okay, the value is an integer. We cannot say okay. We cannot like convert the string to integer to make sure that we don't have maybe we receive a letter and we don't want to like change this letter to an integer because we will say I'm not able to pass from from a string to integer because this is not an integer. Okay, so what we do is the function parseInt. ParseInt, it's only looking for an integer. So when it finds the integer, it will translate it to the value. Okay. So here we are reading our value, so our value will be this one. Okay, now that we have the value, what we can do is say, okay, let's draw what we want to draw. Let's put a background. Let's fill. Let's put it right here. We'll create a rectangle. It will start with in the corner in this position, for example. And for the x and y values, this is the width and the height. So the width will be our lecture. So let's say the width is the value, is the val variable, and the height it can be a fixed value, like for example. Okay, so like this, let's try it. Serial communication only allows you to communicate in one port. So if you have here this serial communication here open, you try to open this one, which it will say no, a serial port this. See, okay, or this you cannot open because you haven't opened here. So you have to close this one. So let's close this one and try to run it again. Know what happened, but here we have our rectangle, and then if I put more light to the LDR, you see that the rectangle is growing because we defined the width of the rectangle with the lecture of the LDR. Okay, like super simple and super straightforward. No? Okay, also like to make it fancier, let's write which is the value. Okay, so let's put it here. You can so like create the text. So text is well its value, and I want to put it in, I don't know, let's say this starts at 100. Let's just start at 150 plus the value. So it's always on the right side of the bar, and the height is 470 because 470 it's like the middle point. It's 450, but like this is a good heart center more or less. Okay, you can see here the number is super small, the text. So we can say text size, let's say 40. Don't know. We will look. Okay. Okay. See, there's some problem now. See, this is the problem with sending strings. You can have lecture that you don't want. So, so now here you have the value, okay? Oh, like fancier. Let's stay with this example and make something fancier. Okay, let me introduce you the 3D processing. Okay, so here when we define the size, we can define also the rendering mode. Let's say. So it's processing 3D. Okay, so we have this processing 3D. Okay, perfect. And let's say, okay, here we can create. It's create. It's the processing 3D. What it allows us is to create like different. Different 3D shapes. So, for example, we can import OBJs. We can create shapes like spheres, like boxes, doubles, ellipses, like so it's a lot of different 3D shapes. Okay. So now that we're defining here, we have also now we have our coordinate system is with 3 variables. We have X, Y, and Z. Okay. So let's say. Okay, let's create, instead of creating this, we can comment this one. I don't have it really prepared, this one, so let's see if it works fine. Okay, so I will create a sphere. 200. This is the size of the sphere, so it's the diameter of the sphere. I don't know if it's the diameter or the radius. I think we can go to the sphere mode and change it there. Okay. So this sphere can translate this sphere to the middle point. So let's say with so we'll center it in the middle back here. Okay. So this is creating a sphere. This sphere I can fill it with a color. Let's say let's make it yellow, same as the other one. We have a flag here. Okay. We can fill this sphere. Now let's see. Let's do a thing. Let's comment this to just try to test the drawing of the sphere. Pretty slow. Okay, here we have our sphere, super fancy, but we can hide the stroke. So let's say no stroke to hide these lines. Okay, so here you can see all the faces of the sphere. So these triangles are the faces. So we hide the stroke, we will see like a normal sphere. Okay, and then also we can define a light to see this sphere. So for example, let's go and say, there's no stroke here. Everything has stroke. And before translating anything, this field goes out. So before translating the origin, let's create a directional light. And we can define here the value of the light. So let's say it's a white light. And we have to define the direction of the light. So let's say the direction is from the x positive, so 1, 0, 0. Let's see what happens. See, it's loading. Okay. My computer is a little bit, okay, nice light here. Huh? You can see that the light is coming here from the X value. So now what we can do is say, okay, I want this light. You can see that we set the light in white. So the color only reflects the yellow one because it's yellow, okay? So what we can say is, okay, this light values here, that it's like the color of the light. Let's define them to the value of our reading. So like this, we can have a fading light effect with the value of our reading of the LDR. Okay. Now, we will have a problem here because this value is from 0 to 1023, and this is only allows you to use the.
We have to map them.
50. Yeah, let's map them. So let's make map of the value. This value, it's an integer, so I have to change it to a float. Float of the value 0, 0. Mapping is just redefining the range of your lecture. So now we have values from 0 to 123, and we want values from 0 to 255. 1023. So here we have the mapping function. I don't know if it will work like this or if I have to like rewrite the value as equals map. Let's see. Yeah, it's working. So here we have our more or less map. It's fading here. Okay. Let's do one thing to see it even better. Let's say here in the Z, let's show it as value 250. So here I will also move the Z direction of the light with the value. So let's see, slowly here. So here it's with the more or less zero value. Here, it's lighting the whole sphere because it's moving the light also in the Z. Okay? So you can see like super easy 3D rendering here. Okay. Also, let me show you that here you have examples and you have like a lot of examples. It's opening. Yeah. Like this. Like this. So yeah. I lost my examples folder. So it's here, but I don't know what it is. Okay. See if I can re-get it. Here, okay. Here you have like examples of anything, okay? So I don't know, if you want different colors, if you want input, for example, if you want the keyboard input, like this one, super easy. Only you can define here the void key pressed. So whenever you press a key, this void will run, this loop will run. So here it says if the key is a letter, then do something. If not, do another one. So we will run here. We're just controlling, super small, we're just controlling our interface with the keyboard. Okay. I think here we're drawing squares, different colors. So you see that there are a lot of examples here that say shapes. Look, for example, let's load another design. If it wants to open. Here it is. Okay, here. This is a predefined object that they have in the folder. When you download processing, you download this, like this assets folder. You will have it. Do it slow black. Amazing. See, so you can create your 3D models and show them here in processing. Okay. Okay. Let's go for the last example. That it was the one with the.
Can I ask something?
Yes.
What's the difference between serial string until and buffer until?
It's more, yeah, it's the same, but when you read string, you are like defining that this lecture is a string. If you read buffer, it's reading the bytes and buffer the bytes. Okay. So it's the same, but just changing the type of the value of the variable that you're reading. Okay. So for this example, I have here like three buttons and 3 LEDs. Those are connected, the button and the LED, to the same port. So changing it to input and to output, you can light up the LED or read the sensing of the button. Okay. This is a simulation of my assignment last year, because I don't have the URL here, so I cannot show it to you like here in live. But this is like more or less the same, but done with only 3 buttons, three LEDs and 3 buttons. Okay. So let's start here with the Arduino code. Here, the nice thing here is it's to see how. Let me delete this one because I had forgotten before. No, 3. Okay. Of codifying your message to send like much more specific and much more stable message to make sure that your lecture is the correct one. So here I define all of them as outputs to light the LEDs. Well, here I have the LEDs connected the other way around, so they are connected from voltage to the pin. So it's like inverse logic. So if you put high, the LED is low, it's not glowing, and if you put low, it's glowing. Okay. So this is just to make sure it starts with everything turned off, and then you start the communication here. So then I say, okay, if there is serial available, let's read what we are getting, and let's say, so how I codified my message, it was okay. I wanted only to send one byte. So we know that 1 byte. Let me open. So, oh, sorry. Okay. So, 1 byte are 8. Well, let's do the same, no? In order to
Maybe Josep, if you press Control plus or something like that,
Yeah.
it creates a combination of
like this, control and the scroll wheel. Perfect. Thank you, Oscar. So 1 byte are 8 bits. Okay, so 1 bit is a 0 or a 1. So a byte is equal to 0, 0, 0, 0, 0. Okay, so in 1 byte, you can send information of 8 things. As I'm working in digital, I define, okay, with only 1 byte of information, I want to send everything. So I define like this byte here, this bit will be the one in charge of the mode. So if I send a 0 here, then I will be sending, okay, I want to here, let me put it like screen on screen. Sorry. This one. Okay. So let's say, okay, if I put a 0 here, what I want to do is to write what I'm lighting up in the write the state in the computer. Okay, so in processing, it will read what the buttons that I'm pressing here. Okay, if this is a 1, it's the other way around. So I will light up the LEDs from the processor. Okay, so this is the mode, right? And this information will be the information of the state of the LEDs. So if it is a 1, it will be high. If it is a 0, it will be low. Okay. Okay, sorry. Sidewalk is bothering here. Okay, so this will be like the message, no? So if I want to light up, the blue LED, for example, it will be 0, 0, 0, 0, 0, 0, 1. Okay, so with this one, it's saying, okay, you have to light up this LED. So this is just sending the state. In last year, in my ukulele, what I did, it was sending, as I had in each of the frets, I had four LEDs because I have 4 strings. And then here I define the mode and also which fret. Okay, so I model a communication protocol that with 1 byte, I send like everything. If I want to write, if I want to read, which fret and which string, okay? So making a codified communication was much better than, because you will avoid a lot of problems, okay? Reading the string, you see in the processing, we had some problems that we press play and it was not working. It was because it was reading strange things, okay? So here, what I say is, okay, if I send here a 1, I want to enter reading mode. If I send here 0, I want to enter write mode, okay? So here in the Arduino, what I say is, okay, if serial is a 0, if there is any byte send it, let's read this byte. So if the lecture is 16, so 16 is 16, 0, 0, 0, 1, 0, 0, 0, 0. Okay, so I say, okay. Well, I see that it's not super optimized, but it's okay. So if I send here, I'm changing mode to read the state. Okay, so if I want to read the state, I send first the 16, then it will enter this function, and then I will send something else to read. Okay. If the first lecture is not a 16, this will be the state of the LEDs. So I will write the state. Okay, so it will be something like, I don't know, 0.0.101, for example. So like that, the red and the blue LEDs. Okay, so let's start with the read state. So the read state, what I did is, okay, I define all the pins as inputs because what I want to do is reading the state of the buttons. And I create a bit that is the state byte. Okay, so here I create a state byte. It's not included. So I create a state byte and I say, okay, I want to write in the state byte, the bit 0 to the value of the negative of the digital read because the logic is inverse here. Okay, so I'm writing the 0 if the button is not pressed and no 1 if the button is pressed. Okay, and then I send this state. So I will send the byte with only these 3 bits on or off, and the processing will read them. Okay. The other function is the write state. So this write state, I wanted to do it like this because like this I can show you a little bit more of byte shifting and the ports of the Arduino. So if I want to write the state, what I want to do is change first of all define my LEDs as outputs to light them up. So I did it with this function here. This line of code is defining outputs with the ports. Okay, so we have like the Arduino. It works with C. So in C programming, we can access the address of the ports. So we have a byte that is TTR and an X. This X is a letter, can be A, B, C, or D. And each one of these letters have a number of ports. In this example, I have the LED is connected to the pins 3, 4, 5, and 6. And I know that the port D, so this letter is port D, okay? It's the port that it's a byte and it has 8 bits, 1, 2, 3, 4, 1, 2, 3, 4. And this is exactly, this is port pin 0, pin 1, pin 2, pin 3, pin 4, 5, and 6, etc. Okay, so I know those are the digital pins of the Arduino, and those are the pins. Okay, so with the DDR, it's to define the pin as input or output. So if you put an 1, it's an output. Okay, so I define this like this. So I say, okay, for this port D, the ports D, open the port 1, 3, 4, and 5 as an output, as outputs, okay? So to change them, I use the OR operation with the binary number here. But this is about bit shifting, but this is just putting ones in the ones that you want to put, okay? So it's just putting ones without touching the zeros, okay? So these zeros are not acting, are only acting the ones, okay? So I define that the pins 3, 4, and 5 are outputs. Then
well, in the Notepad++, there are 3 zeros, and in the Arduino Sketch, there are 2 zeros before the ones.
Sorry, because this is the other way around. So it's 7, 6, 5, 4, always from more significant to less significant byte. 3, 2, 1. Sorry, thank you, David. So here what I want to open is the 3, 4, and 5. So for this reason, we have 2 zeros. So it's not like this. This is a 0, and this is 1. Sorry. Thank you, David. Okay, and then I define, okay, so this with the port D function, port X, it can be depending on the port. Let's say D now, we can define the state. So as this is an output, if we want to set the state to 1 or to 0, we can put it here. So 1 is high, 0 is low. So what I did here, it's okay. I had the lecture, that is, it was the because here missing something here. This will. Okay, so I need to the lecture first. So if let's change this to higher or equal 16, and I will change the okay. No, sorry. Sorry. No problem. Now here with the lecture, it's the state of the LEDs that I have to light up. So the port B is just changing the pins. This is bit shifting, so I'm making an AND between. So this is the port, okay? Now everything is turned off. So the lecture, let's imagine that our lecture that we want to do is lecture, let's say, are three of the LEDs, all the LEDs light up. Okay, so with this operation here, shifting. Okay, what we're doing is moving these numbers, three positions to the right. So to the left, sorry, here. It's equal to 0, 0, 0, 0, 1, 1, 1. I add 3 zeros here on the left because I move the lecture three values to there, okay? So right here, and then I add this value to here. Okay, so it's just adding. So if you add them, okay. Okay, this operation here, this is a negation. So we are negating this value. So negating it, it's equal to 1, 1, 0, 0, 0, 1, 1, 1. Okay, I'm doing the AND function. So what we're doing finally is 0, 0, 0, 0, 0, 0. And so you find this and 1, 1, 0, 0, 0, 1, 1, 1. So making an AND is if both of them are 1, this is okay. Okay, yeah, because we want it to have it in. Okay, so we have this. We define the port D first as this, okay, to open the value to start with ones here. Okay, and then if I want to light up everything, I have to turn it off because it's the inverse logic here. It's the complicated way here. So AND is saying, okay, if there is a 1 and a 1, it will be, let's change example. Now let's make it to make it easier to see. Let's say it is like this. So I want to light up the red and the blue, but not the green. So it's like this, and here I have the negative that it's like this. So 0 and 1, if both of them has to be 1, so 0 it's not. So 0, so this is equals to 0, 0, 1, 0, 0, 1, 1, 1, 0, 0, 0, 0. So here it's saying, okay, only turn on, like put to go to high the pin of the green LED, And in this case, going high, it's turning it off, okay? Then in processing, let's do it fast because Oscar is waiting. I will open the code that I have. I have it open. I have it open.
So when you are writing the port the bytes, you are making something like set pin 5 high or something like that. It's another way to do the same thing. Okay.
Yeah, it's the same thing, but the thing is that here I'm like in one line of code, I'm turning on three states.
Yeah.
You can turn on 8 pins with only one line of code. So it's like more optimized coding.
Okay.
Okay, it's going in, and here we have the processing code. So it's more or less the same, okay? Those are just variables to change the color or something like this. And here it says, okay, well, I have a mode variable, so if it's 1, it will be writing. Well, if it's 0, it will be writing. If it's 1, it will be reading, okay? And then if reading mode is 1, I go to reading mode. And well, if reading mode really it is the same. Else if mode equal to 0, this will go to writing mode. Okay, this is the same, but I define the writing mode only when clicking inside the button. Okay, so this overrect function is a function that I write here. It's a boolean, okay, that is defining only if it's inside a square. So it's overrect. So if the mouse is inside the X range and the Y is inside the Y range, then it returns true. So this is the way of doing like a button in processing. So you define a boolean saying, okay, it's over my shape, yes. So if you click there, it's a button, okay. So let's go to the important part of the reading and the void writing and the void reading. So when I want to write, it's okay. I enter writing mode. I create a message that is the value of the blue, the value of the well, not the value, like the state high or low of the blue LED, of the green LED and the red LED, multiplying by 2 and by 4 to create the byte. Okay. So if you have let's go back here. So let's say you have the same example. So I want the blue, the blue on, say blue is equal to 1, green is equal to 0, red is equal to 1. Okay. So here what I'm doing is, okay, 1 plus 2 per 0 plus 4 per 1. This is equal to 5. Yes. And if you translate this 5 to binary, you have it like 0, 0, 0, 0, 0, 1, 0. So this is the state of our let, okay? Yes. And then you write the message. So you only send 1 byte, that is this message. That is the state of the LEDs. And reading mode, it's the way around. So you send the 16, so it's reading, and then it's reading from the port. And it reads the state. So you read this state, and then if you add them to, it's the same, no? It's an AND operation, but so it's the state, let's say, same state, 0, 0, 0, 0, 0, 1, 1. So you add them first to this, make the AND operation. You can see as the red is turned on, when you make the AND, the only value that turned on is the red. So you can see here, okay, it's better than 0. The other one is the same, but instead of this one, instead of 1, it's with 2. So the 2 is this one in binary, and then the other one is with 4, but this is this one. Okay, so it's checking the state of these 3 fields. Then so you check the state and you read them. So here you have like the example of the Arduino. Super amazing interface, super fancy. So here it's writing. So if I light up the red LED, it's turning red. Then light up the green, it's turning yellow because it's turning red and green, and blue is turning red because you have all of them. And also you can read the state of the buttons here. So when you press 1, okay, you have the state of them. Okay. More or less all this code you have it in the documentation, okay? And any doubt that you have, you can reach us and we can talk about it. Now I will leave you with Oscar going through OSC. Much more interesting than this shitty interface of the RGB colors. But for the basics of processing, I think you have more or less with this exercise that we went through, you have some of the basics. You can start creating with processing. Then my recommendation is check the examples. I recommend you to check the examples before starting. So like this, you can get ideas for what you want to do. And look for the documentation of processing in the internet. It's pretty nice. And then you also have P5. It's the same as processing, but in the web server. So well, in the browser. So it's super nice, but the communication with your board it may be more complex. So I can imagine that with the Node MCU it will be easier if you connect it through Wi-Fi. But I really don't have a lot of experience with it. I know that with the serial port it's complicated. Okay. So now I leave you with the master, Oscar, the king.
Thanks, Josep.
Well, I'm not gonna give you much more stuff about it. I think what Josep did was already like very very good introduction for the processing part. I just want you to give you a couple of concepts, and I'm going to share my screen very quickly. I don't want to take too much time today. Where is this? Here. Do you see my Firefox?
Yep.
Okay. So the only thing I'm going to talk about is, well, just to complete a little bit what Josep was saying, is that imagine that you want to make processing talk to other things. So you're talking with your Arduino via serial communication, processing is receiving stuff, and then you want processing not only to display something, but also to talk to other things. For example, it could be like a music player, or it could be another program that manages projections, that does like, I don't know, some sort of projection mapping with a real projector or something like that. So you can do that, and I just want to mention very quickly and explain in the code how it's done. Is for those who have a Mac, you can use a Siphon to share the window of processing to whatever you want. A Siphon is a protocol that basically opens an internal communication with other programs and sends that screen over to a certain port. So it could be, for example, a projection mapping program like Nilumin, VDMix, what's the one? I forgot about the name. Anyway, so anything that you can then modify and use for doing some projection. Of course, in other platforms, you will be able to do it. I don't know how, but in Mac, you can do it with iPhone. And OSC is a protocol that is used for sending data used for music instruments, a little bit like MIDI, but with a little bit more advanced addressing system. And also it allows you not only to send notes like in MIDI, but also to send, for example, messages that can be targeted to a specific client. For example, imagine that you have a MIDI keyboard and you want to, while you play your Arduino, do something in the MIDI keyboard and modify whatever synths in or whatever effects in the MIDI keyboard, or at the same time trigger a projection, or at the same time playing some sounds on your computer. So all that is done internally with all that communication is done internally with this protocol OSC, which stands for Open Sound Control, and basically is pretty much the same as MIDI, but with this style like URL type of thing, in which you have different clients with a port, and that you can send them messages in various styles to each of them. As you see, there are quite a few applications that support this thing. From, for example, QLab, which is a program that is used, for example, for doing theater lighting and doing music synchronization with lights and things like that. Max MSP, that was the one I was looking for earlier. Open frameworks, if you want as well, you can, instead of using processing, you can use open frameworks or have two applications running, and so on and so forth. Unreal, Super Collider, Sonic Pi, all these guys listen to OSC, and it's like very simple to send them messages and to start making things that don't have to stay in processing itself. They can, for example, if you feel comfortable, just listen to an Arduino in processing and then trigger other things like music, for example, in QLab. And a lot of these programs are open source or free. And then you can just, I don't know, start trying to make a little bit more like interesting things as well with sound. So let's have a look very quickly about how this works. Well, I'm gonna show you only Siphon. So Siphon is the protocol, and Siphoner is a client. So Siphon has this little logo, and basically is just sharing content of applications inside a Mac. Basically, another client could be listening to it, and then, for example, it's just a video stream on top of which you can make modifications, like, for example, the glitches to an animation that you're making in processing, or if you have a camera, you can superimpose readings of the sensor on top of a video, or modify a video based on the readings of the sensor. I don't know, things like that. Creativity here, like this week, could be even like one creative week in which you can explore this thing. And Siphoner is this application that basically is listening to the screen that you're sending, and you can use this to test that the sharing works. So if you have a Python, so much Python. If you have a processing code and you want to use this, you import OSC P5 and NetP5 for OSC, and then Siphon, you declare it like this. Is it too small, my screen, or is it okay? You can read it.
It's fine. Okay.
Then you have to define the address for the program. In this case, I'm using port 12,000 for OSC, and for the Siphon server, I'm using the local host and 1, 2, 3, 4 support. You start the Siphon server in the setup, and then basically you can just, with this simple instruction in draw, you can say server send the screen, and it sends whatever is being drawn in there. That can be as simple as that. And depending on the frame rate that you set, it will send it every time the screen refreshes. And you can modify that. For example, if you are listening in VDMX or Milumin or whatever, then you can modify that screen, apply chromas, whatever you feel like, and then project it somewhere. And OSC, basically OSC is sending messages, but it can also send what we call like message bundle. A message bundle is a collection of messages that is grouped together so that when they are sent, they are almost sent instantaneously and you don't have delay between, for example, when you press the button on the Arduino and when you start triggering some sounds on your computer or whatever else. So here you create a bundle, and then inside the bundle you create what we call patterns. So inside the bundle, first you have to add one message, and that message has to be targeted to someone. For example, I want to send a message to my music edition program or my synthesizer. So I set the pattern, for example, synthesizer, and I say, okay, I'm sending this variable to this program. I add the value and then I clear it. At the end, then I can say I want to send another thing. For example, I want to say I want to send another variable to a video editing program. So I add a second pattern, and that will be sent to another guy. And at the very end, I just send the whole thing. I send the bundle to both programs, one to the music production program and the other one to the video editing program. And every time that I go back again, I create a new bundle, I send the variable, and the other two receive it. And you see that this is quite compact and flexible. So you could be, for example, again, sending the screen of processing because you have, I don't know, as an animation that you're doing very simply in processing, but that you want to build more complex glitches with a nicer interface. So for example, you could use something like this other program for like VJing, let's say. So, and you can receive that and apply different things and then make like a mapping, whatever. So that's pretty much it. I think what Josep covered and with this, I think also Josep did not OSC but MIDI. So probably you can also like put a little snippet or something so that if people want to also trigger sounds from processing, you can also do so by sending MIDI messages, which is more or less like OSC, but with a different protocol. So you could, for example, every time that you press the buttons in the Arduino, it's like you were playing a piano, for example. And Josep did that last year, but instead of a piano with the ukulele.
It's super easy. It's just a library of processing called MIDI-bus, I think. Little MIDI-bus, something like this. And it was pretty nice. It has some delay, but it's okay. Like for easy things, it's okay.
And just one thing is now, I mean, you can stay in the processing part and make a visualization, but if you explore a little bit more, and as always, if you have time and you want to, I encourage you to do so. Always look out for delays. What Josep was saying is quite important, and trying to optimize each step of the whole process is important because you can make an interaction quick just by trying to reduce like let's say the delay that you put in each of the steps. For example, what Josep did by optimizing how he sends the code for each of the buttons optimizes a lot the response of the system and is almost instantaneous. the same way as if you do, for example, from processing to something else, and you want to trigger a sound every time you press a button or something like that. And yeah, that's it. And also you can use this not only for these things, but I don't know, make more complex things. Like for example, when you have OSE or NetP5, you can send messages to somewhere that is listening on the internet or on a local network, for example, a Raspberry Pi, and that Raspberry Pi can be triggering something else, etc., etc. So you can start building a little bit some systems as well. Yeah, I have nothing else to add. Do you have any questions or something? I know that it was super fast.
I have a question I wanted to ask at the beginning. How is processing different to P5GS, and what do you recommend? And if basically processing can be also used with JavaScript, or not understanding the connection?
So I think I haven't used that much P5, but I think P5GS is the same as processing, but that works on the browser and working. I think that you can write Java as well, but it's written in JavaScript, so it is like running on the browser.
Okay, and can you embed processing into HTML or CSS?
No. So you could, for example, write something that is triggered when, like a JavaScript function that is triggered when you, for example, click a button, and you have to link it via JavaScript. And I don't think that there's a way to put processing in the loop. It's, for example, if you want to do like more complex interactions or things like that, you can go onto like JavaScript visualizations and things like 3GS or D3.
D3 actually is D3. 3GS is an open web GL to make three-dimensional, like imagine like as a three-dimensional viewer of 3D models and super big libraries to make interactions. It's about more like online web rendering.
Yeah.
I will say that D3 is what you're looking for. And actually, they always state that a coder that knows D3 will never have problems of work, because the libraries are quite complex, but if you know how to use them properly, like everybody hires you.
Yeah, and also if you want, there's this one called Tone.js, which is something similar, but for working with audio. So if you go to demos, like a synthesizer, you could make like a synthesizer and listen. I don't know if you listen, if you hear it, but you can have like more like musical experiences in the browser as well. And all these components are already like off the shelf, let's say. So you could map them to what different inputs or other things.
Yes.
And they're
Also,
quite nice. Like
P5. I think so. You can like embed a P5 in an HTML, like the code, like just make a snippet of the P5 visualization. So I send you here in the chat. I put a link of a like a tutorial on how to embed P5 to HTML. Okay.
And that's it. Are we gonna do now the Edu's part? Should we take a break first and then we go on, like 5 minutes?
Yeah.
You want to go straight away, Edu?
Guys, do you want to break or not? Just it's a moment to talk.
5 minutes is good.
Be nice.
Okay.
Cool.
Thanks,
Put some...
Josep and Oscar. Very nice.
Yeah. Bravo, Josep. Y Oscar.
Bravo, Josep.
Oscar shows me everything. He's the master, so.
Stop.
It's